Hi class, today I want to go over significant figures and how to determine the number of significant figures that a measurement has. So, what are significant figures? They're simply the numbers in a measurement that contribute to precision. And we know precision is how close a set of values are to each other. So utilizing significant figures, we can ensure that we have precision in our measurements, meaning that if you ask 5 different people to give you the measurement of an object, they will give you an answer that is precise, meaning all 5 of their measurements will be close to each other. Because of this, significant figures only applies to measured values. So for instance, things that are considered exact values are conversion factors, counting objects. They don't abide by significant figure rules. So for example, 12 inches equals 1 foot. That's a conversion factor. 12 inches is always going to be equal to 1 foot. They're the exact same thing, they just have different units attached to them. We would not consider these as significant figures. Other exact values are counting objects. Let's say I have 5 dogs, I have 3 basketballs, um, 2 set of wheels. Those are counting objects, so we wouldn't take into account significant figures for counting objects and exact values or conversion factors. All right, so when we're determining the number of significant figures that a number has, we have to abide by some rules. There are some simple rules. The first rule is that all non-zero digits are significant. So that means any number that's not a zero is going to be considered a significant figure. So for example, if we have the number 2.3845 and I asked you how many significant figures are in this measurement, what would you tell me? I have 1, 2, 3, 4, 5. 5 significant figures. They're all non-zero digits, so all of these digits are significant. All right, the next rule is that any zeros between non-zero digits are significant. So let's say, for instance, I have the number 101. I know that this 1 is significant and this 1 at the end is significant because they're both non-zero. This 0, because it's between two non-zero digits, is going to be considered significant. So if I said, how many significant figures does the number 101 have, you would tell me 3. All right, the next rule is that zeros to the left of the first non-zero digit are not significant. So for example, if we have the number 0.0025 and I asked you to tell me how many significant digits or significant figures are in this number, what would you tell me? A trick that I use is when you're counting significant figures, you always start counting on the left-hand side and you always start counting with your first non-zero digit, your first non-zero digit. So if I start counting on my left, my first non-zero digit is going to be what? It's going to be this 2, right? So the 2 is my first non-zero digit. So this 2, of course, is significant, and this 5 is significant because they're both non-zero digits. These 3 zeros in the front, they are not significant. So this number would only have 2 significant digits, right? So always start counting on the left-hand side and always start counting with your first non-zero digit. These zeros, I should note, in the front are considered placeholders. They just tell us that this 2 is in the ones, tens, hundredths place, right? But they're not significant. They just hold the place so that this 2 can be in the hundredths place and not in the ones place or in the tens place. So these are placeholders. The third rule is that zeros to the left of the first non-zero digit are not significant. And so that's basically the same as rule number 2. So if we have the value 0.081, these zeros to the left are not significant. Any zeros to the left of the first non-zero digit are not significant. And the last rule is that all trailing zeros are significant, but that's only if a decimal point is present. So if I have the number 82.0, and I said, how many significant figures does this number have? Of course, the 8 and the 2 are significant because they're non-zero. But what about this 0? Because it's a trailing 0, which means it comes at the end of the number, and because this decimal point here is present, this 0 is significant. So 82.0 would have 3 significant digits. Okay? Now let's look at an example of a decimal not being present. If we had the number 250, and I said, how many significant figures are in this number? Of course, the 2 and the 5 are significant, but this 0 is not significant because there's no decimal point present. So without a decimal point, there are only 2 significant figures in this number. If I add a decimal point, if I say 250.0, then all 4 of these numbers would be significant. So there would be 4 significant digits. However, this is only if a decimal point is present will those trailing zeros be significant. All right, so let's test it out. Let's try some problems. So in these problems, we're going to identify the number of significant figures in each of the following numbers. So let's look at 0.001245. How many significant figures would that have? Remember, when we look at significant figures, we start counting on the left-hand side, and we start counting with our first non-zero digit. So my first non-zero digit is going to be this 1. And then, of course, the 2, the 4, and the 5 are also significant because they're all non-zeros. So this number will have 4 sig figs, okay? Let's look at the next one, 12.56. Now, all of these are non-zero digits, so they're all significant. So there are 4 sig figs in that number. 0.58. That first 0, okay, is a leading 0. It's not significant because remember, when we're counting significant figures, we always start counting on the left-hand side, and we start counting with our first non-zero digit. My first non-zero digit is this 5, and of course the 8 is also significant, so this would have 2 sig figs. The number 12, they're both non-zero digits. They're both significant. It would have 2 sig figs. The number 10, all right, of course, my 1 is significant. What about this trailing 0 here? Is that significant? No, it is not significant because there's no decimal present. Remember, if there is no decimal present, a trailing 0 is not significant. Here we have 10.00. All of these zeros are significant. Why? Because these are all trailing zeros and a decimal is present. Because a decimal is present, all of these zeros are significant. So there are 4 sig figs in this number. What about 10.02? How many sig figs is in that number? These 2 zeros, they're between 2 non-zero digits. Remember, one of our rules was zeros between non-zero digits are significant. Because they're between non-zero digits, all 4 of these are significant. Here we have 10.020. How many sig figs does this number have? Okay, these 2 zeros are between 2 non-zero digits, so they're significant. This 0 here is a trailing 0, but there's a decimal point present, so it's also significant. So all of these digits are significant. So in this number, there would be 5 sig figs. 1, 2, 3, 4, 5. All right, and what about the number 200? There are trailing zeros here, but there's no decimal present, right? So that means they're not significant. So 200 would only have 1 sig fig. All right, when we're doing mathematical operations with significant figures, our answer can only be as precise as our least precise measurement. There's 2 separate rules, one for adding and subtracting, one for multiplying and dividing. When we're adding and subtracting numbers, we only look at what's to the right of the decimal point. So when we put this number on our calculator, what are we going to get? We're going to get 12.476. However, how many figures are to the right of the decimal point in 2.256? There are 3. How many are to the right of the decimal point in 10.22? There are 2. So that means our answer can only have 2 digits to the right of the decimal point, which means I can only have my 4 and my 7. So I'm going to look to the right of my 7, there's a 6. Because that 6 is greater than 5, I'm going to round up. So my answer with the correct number of sig figs would be 12.48. And if we look at this one here, subtracting, same thing. I only look at what's to the right of my decimal point. In 42.256, there are 3 digits to the right, and in 0.22, there are 2 digits to the right. So when I plug this in my calculator, I get 42.036, but my answer can only have 2 digits to the right of the decimal point, which means the 0 and the 3 are the only digits I can have. I look to the right of the 3, there's a 6. That means I round up, so the answer will be 42.04. Okay? All right, now when we're multiplying and dividing, we look at the total number of significant figures. So we don't just look at what's to the right of the decimal point when we're multiplying and dividing, we look at all of the numbers. So how many significant digits are in the number 53.555? They're all non-zeros, they're all significant, there are 5. How many are in the number 0.027? Remember, we start counting on the left and we start counting with our first non-zero digit, which is 2. Of course, the 7 is also significant because it's non-zero. So there are only 2 sig figs in the number 0.027. Okay, when we put this in on our calculator, we're going to get 1.518. Because our least precise measurement is the 0.027 because it only has 2 sig figs, our answer can only have 2 sig figs also. So that means we can only have this 1 and the 5. We look at what's to the right of the 5, it's a 1. That means we leave this 5 the same. So the correct answer for this would be 1.5. Okay? All right, so we can work out a few of these. We have 2.25 times 5.0. We're multiplying. So when we're multiplying, we look at the total number of sig figs in each number. 2.25 has 3 sig figs because they're all non-zeros. 5.0 has 2 sig figs. The reason why is because this 0 is a trailing 0 and there's a decimal point present. So 2.25 times 5.0 is going to be 11. That means our answer only can have 2 sig figs. 3.22 divided by 2.2. 3.22 has 3 sig figs. 2.2 has 2 sig figs. That means our answer can only have 2 significant figures. So our answer would be 1.5. And then lastly, 2.25 has 3 sig figs. 0.50, how many does that have? It has 2 because we start counting on the left with our first non-zero digit, which is this 5. This 0 is a trailing 0 and it comes, there's a decimal point present, so it's significant. So there are 2 sig figs in 0.50. And so when we work this number out, we're going to get, I believe it's 1.1. Because that means that our answer can only have 2 significant figures. Okay? So 2.25 times 0.5, yep, that's 1.1. All right? All right, so if you all have any questions about significant figures, please let me know.